Lesson 3, Geometric Sequences. For a geometric sequence, there is a common ratio between consecutive terms, so you multiply by it to get to the next term. For example, these are geometric sequences. Here, we can see to get to the next term, to get to the next term, we're multiplying by 2 every time, so it's a geometric sequence. Here, we're doing something similar, but instead of 2, we're multiplying by -2. So the terms flip from positive to negative every term. A general form for a geometric series is this, where it would be AR squared, AR cubed, and so on and so forth. We can see that here, the power of R is 0 for n equals 1, it's 1 for n equals 2, 2 for n equals 3, and 3 for n equals 4. You can see that this number is just this -1. So we can write a generic formula for the nth term as un equals AR to the n minus 1, where A would be the first term, R would be the common ratio, and n is the position, or the actual nth term. Let's do an example. Let's find the nth term of A, 3, 6, 12, and 24, and B, 5, minus 2.5, 1.25, and minus 0.625. For part A, 3, 6, 12, and 24. We see the first term is 3, and we're multiplying by 2 every time. So we can say the nth term, using the formula, is 3 times 2 to the n minus 1. For part B, we can see to get to the next term, we're just multiplying by minus 0.5 every time. The first term here, A, is 5, and R would be minus 0.5. So the formula for the nth term would be 5 times minus 0.5 to the n minus 1, or 5 times negative a half to the n minus 1, or you can do a little bit of rearranging with algebra to get un equals minus 1 to the n minus 1 times 5 over 2 to the n minus 1. Let's do another example. We're given that the second term of a geometric sequence is 4, and the fourth term is 8. We're given that the common ratio is bigger than 0. Let's find the 11th term in the sequence. So, the second term using the formula would be u2 is equal to AR, which is 2 minus 1, which is just 1, and that's equal to 4. u4 would be AR cubed, which is equal to 8. If we do 2 divided by 1, we get AR cubed over AR is equal to 8 over 4, which is 2. The A's cancel here, and the R cancels to 2, so we get R squared equals 2, so R equals plus minus root 2, but R is bigger than 0, so R equals root 2. So we can say, to find A, all we do is put this into the first equation. We get A root 2 equals 4, so A equals 4 over root 2, which is 2 root 2. So we have the generic formula un equals 2 root 2 times root 2 to the n minus 1. Plugging n as 11, because we want the 11th term, we get u11 equals 2 root 2 times root 2 to the 10, which is 64 root 2. Let's do one last example. Which term is the first in the sequence 3, 6, 12, 24, etc. to exceed 1 million? Let's write the generic formula is AR to the n minus 1. We have A equals 3, and we can see the common ratio is 2, so it's 3 times 2 to the n minus 1. We want this to be bigger than 1 million. Dividing both sides by 3, we get 2 to the n minus 1 is bigger than 1 million over 3. And if we take the log base 2 of each side, we get n minus 1 is bigger than 18.35 to 2 dp. So n is bigger than 19.35. And because n is an integer, n has to be bigger than or equal to 20. So therefore, the 20th term is the first term. And that is it.